Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Alright, we will start and welcome everybody to this live channel. Right, I'm doing this sharing of the circle concept just to ensure that everybody has got the right understanding for the concept for circles. Now, obviously, we had done the exercises as you remember, and I think everybody has got a good understanding of all the concepts, right? But maybe you might want to know some concepts or the fundamental first before we actually discuss the exercises that you were given. Right, so welcome again to this, and I hope you enjoy your time over here. And of course, the holidays might be over, I guess, but or rather might be over soon. And hopefully, you have fruitful holidays so far. And of course, in a few months' time, you will be taking your O-level, right? So that will mean that the coming weeks, right, you probably want to really put a lot of time onto your studies. Okay, so here goes. Okay, so what am I doing now is first I want to cover the equations of a circle, and of course that involve knowing what the requirements are. So let's start with this first, the equations of a circle. And when they tell you that to write the equation of a circle, they literally want you to tell them to list it out in either standard form or general form. And the requirements that you need, in fact, is basically the center of the circle. Let me just write it down. The center, right? The coordinates, obviously. And because why? Knowing the center, you'll be able to find the x and y. And of course, you need to know the radius. Now, so I will just run through with you the basic fundamental first. Okay, so that is what I will go through with you. So, and of course, if you can see over here, the standard form is actually x minus a squared plus y minus b squared equals to r squared. And if you notice, right, if let's say you have a center coordinate of maybe 2 and 3, whereby x is equals to 2 and y is equals to 3, right? And of course, how do we form that is definitely, bringing the 2 over so that you have got the x minus 2 and you have got the y minus 3, right? So this is very important because later on I will share with you, if you're given the general formula, how come initially I would want student to derive using completing the square, but moving forward, if you know how this is formed, then it will be easier for you just to memorize the relationship, you see. So let's have a look back here. It's like you have this when you bring it over to the left side, and by doing that, that's what you see on the left side, right? And of course, if you know the radius, let's say for instance it is actually going to be 5. So with a radius of 5, and of course we can really rewrite this as x minus 2 squared plus y minus 3 squared, and of course that would be equivalent to 25, right? This is pretty straightforward, am I not right? So this is what you see over here all the time that we are practicing. So that something must be in you is like, okay, when it is about circles, the geometry of it, okay, let's be real, let's know our center coordinates as well as our radius, okay? So this is something which we need to know. And of course, I've actually gone through this, so I'm not going to talk about that. I want to go on further to something else, okay? Give me a minute, I might want to bring in the right presentations over here, okay? So this is what I did. Now I've done this, so you just have a look at it. And the next thing is I probably want to share with you. Let's say for instance you're given the center instead. So you're given a center and a radius, so you probably is able to form that yourself, right? So not a problem. And now the thing is this, what if I tell you something else? For instance, circle touching axis. Probably you have seen that. So very interestingly, if let's say a circle touches the axis, right, how can we actually come up with the so-called the circle, the equation of the circle? So let's discuss this. Let's say example, you're given that, okay, you have a center and this center actually touches the x-axis, okay? So sometimes, right, in fact most of the time when you will have a question regarding circles, the best thing of course is to actually draw something out first so that you can visualize. I think most of you are doing that. That's a very good thing. Now the question is, of course, there's still a need to know certain type of question that can come up so that when the exam comes, right, automatically you already know what to do. So very interestingly, even though I have encouraged you, especially for paper 1, right, I mean to really focus on calculus as well as trigonometry, I mean, we know that there are certain percentages even in a paper 2 that will, you have this type of question that will actually be out there. So you don't want to miss that mark as well. So why not, try to be exposed to the different type of circle questions that you will see, right? And every time you see them, right, of course you will initially you will need to draw that out, but do note that they can ask it in this way so that when they ask you again in a real exams, you know by default what is expected, you see, instead of reinventing the wheel and drawing it out, because in exam time is also a factor, you see. So that's why we encourage you to practice, okay? So coming back to this, now let's say you have got a circle that touches the axis, right? And now let's have a look at it. The center is actually -5 and 3 and it touches the x-axis. Okay, so if it touches the x-axis, of course you can draw something like that. there must be something that tells you that, okay, if it touch the x-axis, right, the radius can be found. Okay, so I want you to trigger in you, okay, that when a circle touches the x-axis or even the y-axis, okay, so that means circle touching axis, radius can be easily found through one of the coordinates. Okay, so for instance, for this one, okay, you have got the -5 and 3. We know that it touched the x-axis, so you can see over here, assuming that it is like that on the left side, by default you know that, okay, your radius is actually supposed to be 3, so to speak. Okay, so do take note of that, and that is how we do that. So for instance, if it touches the y-axis, okay, so very sure we know that it is actually going to be of a radius of 5. Okay, that is depending on what it is. So by default, if you know something like that, please know that the radius is already there for you. Okay, so please understand the very first thing, note it down. Circle touches axis, radius can be easily found from the center. Okay, so that's what I need you to know. Now there will be something like this as well. So for instance, if you're given a circle with diameter, I call that the endpoints. So what does it mean by the diameter that creates the endpoints? Is like this. If you have got a coordinate A and coordinate B, and they tell you that they pass through the center, so there are certain things that they will say. Sometimes they will not be very direct. They will tell you something else. They will say, okay, this thing is on the circles. Okay, so there's something that you need to be aware. They might not tell you that this is the diameter, but there are certain clues that they will share with you. For instance, they might say A and B, they are on the circles. Okay, so now in the sense that I did share with you, this could be a chord questions. Okay, now A and B, if it's on the circle, is obviously a chord lah, but I just want to tell you that it's not definitely a chord question that I want you to focus on. If they say A and B is on the circles, but it actually passes through the center, so then it's easier for you. You know that it is actually the diameter. Can you follow? So there's something which you probably want to be aware, because it's easier with this. You notice, right? If pass through the center, right, we know that A and B basically is just your diameter. You can easily, you can easily find a distance formula if you want. Okay, that means between B and A, find the distance formula. Still remember distance formula? Okay, for instance, for this one, we can just use maybe the difference between x. So it's 10 minus 4, okay, or 10 minus -4, and you square them. Okay, and then you add, okay, plus, okay, the difference between the y coordinates is 6 minus 0, you just square them. Okay, something like that. This is called the distance formula or the line segment. So basically, if you can find that, and whatever you get is basically the diameter, obviously lah, then you can divide by 2 to get the radius. For instance, for this one, you get a radius that will be, of course, in this case, square root of 58. Of course, and let's say for instance you have done this, you have divided your diameter by 2, and you found that it's actually square root of 58. Note it down. And interestingly, how do you know what is the center? You see, but you notice A and B are diameter, so you can find the midpoint, right? So this is actually very interesting. You can find midpoint. So in fact, it's very interesting. It's like every time there's a chord question, the midpoint automatically comes in, right? So diameter also the same, right? You can think about it that way. Find the midpoint, obviously. So once you have found this midpoint already, that will be the center as well. So with these two known, it is not a problem right now. You can just form the equation of a circle. Okay, so that's how we do this type of questions, right? So I'll go through with you. I'll send you the notes, obviously, but just hang on a second with me. Let me just go through all this first, right? So that's how we do this. And let me move on to the next one. Okay, so let's say if you look at this, it's like, okay, asking you to find the center and radius from equations, right? So there are two ways, obviously. The first thing is, of course, they give you the standard form, and they want you to tell them the center and of course the radius. This one I probably don't want to go through, you should know this by now. But the question is, what about the second method is like I give you maybe a general form, for instance. Okay, you were given a general form and you are required to come up with the the center and as well as the radius. Okay, later we'll discuss this and see whether there's anything we can take away from that. Okay, but the question is, at school, some of the we in your 360 book, if let's say you are using one, they of course directly ask you to see the correlationship by expansion and knowing the relationship, so it's easier for you to memorize. But in fact, that was what I was against. I do not want you to memorize, because by expansion and of course by looking at the expansion and coming out with the center, I felt that it isn't very convincing. That's why I wanted to encourage students to do completing the squares. But having said that, if you do a completing the squares, it might be redoing certain things again, you see. So I would rather sometimes you go and memorize, but knowing why it is like this. Okay, I know it sounds kind of a bit weird right now. We are already a few more months and it's exam and I'm talking about this again, but let me just explain why is that so. Because sometimes you might be given questions that involve K, and you do not know your K, and I would think that if you do completing the square, it can take some time to do that. So rather to do that, it will be very, very interesting to actually try to do the memorizing. Okay, so that is why I do encourage you to do that sometimes. Okay, let me just go through this review to explain. Okay, so coming back to this, our worksheet that you had. Okay, now together with the solution, obviously. So let's have a look at it. Sorry, that's from the school. Yeah. Okay, we'll go to section B. Let me just run through some of this, then you probably will understand. Okay. Let me just go to one that has got the formulas already there. Let's say they do have. Okay, we'll use number 8 as an example if you do not mind. Okay, sorry about that. Let's use number 8 for our examples. Now, let's say for instance you're given this. Okay, let me highlight this for you. Okay, notice there's a K over here. Now, so I was just sharing. Let's just imagine the K. The K was maybe like let's see, the K is 35. Okay, let me just put it in and share with you. Let's say now I have got this x squared, okay, plus y squared minus 4x minus 12y plus k is equals to 0. Okay, now let's say, assuming now I know my k is a 35. Okay, now because I want to explain to you what if I know the k, but I want to complete the squares, or should I memorize? Okay, now I was an advocate of in completing the squares, but I guess sometimes it would be better to memorize. Okay, now why is that so? Maybe let's get down to the basics. Okay, because of course if you memorize that works, but if you notice, what I'm going to share with you right now is this. Even at school I do share with the class students, it's like try to group them up together. Isn't it not true? So I'm going to group it up. So you see over here, I'm going to group this together, and of course the y will be grouped together as well. So now if you have got this, now notice something. I want you to do something interesting. Look at the constant 35. Catch this. I'm going to throw this to the right side. So this is negative 35. Okay, do note what I'm trying to say. This is negative of this. Okay, because I throw it to the right side. Okay, now over here obviously you need to complete the squares, right? So let's do it very quickly. It's a negative, so some of you are so good at it, I'm very impressed. Okay, so this is definitely negative 2 squares, obviously, right? And of course this is minus 6, and of course you square them. Now you notice, because you actually try to find the b, okay? So what did you do to your 2ab? You see, your 2ab of course becomes a b by dividing by 2, right? Agree, right? So what happened is this: on the right side, of course, because you inserted something that allows you to complete the squares, what was it that you inserted? You see, so basically you inserted can you see what happened? Yeah, so this is actually 2 squares, you notice, and of course this is going to be 6 squares. So, and of course you can just add and whatever, right? And that's it. Now the thing is this: memorizing helps a little bit is because we can see for sure that if you notice, right, what is this, you know, and what is this, right? So we can in fact already tell that, okay, we just have to divide this by 2, right? So obviously you know this is going to be x minus 2 squares lah, you know. And of course in your textbook they will tell you to negate this, okay, negate it and divide by 2. And the reason for negative it, or rather negating it, is because when you shift this to the other side it's positive, isn't it not true? That's why it has to be negative of the half of 4. So that's why you have your x is equals to 2. Okay, can you all follow? So don't memorize for the sake of memorizing. No, why is it, you know, the half, you have to halve it and then you have to negate it, because you have to move it to the other side, remember? So obviously y of course is just a 6, right? We all know that. Now the question is, how about this radius? So remember, how come we remember it's like this, like that? The radius is usually of course a square root, because this is a square. Now you notice that this is 35 on the left side. Do you still remember what I did? I threw it to the right side, right? So of course this has to be negative 35. Okay, right? Can you follow? Now obviously I added this and this. Oh, so there's nothing to worry for this if you know that this is going to be 2 and 6. Now whether it is negative or not, I do not care, in fact, because you need to square that, you see. So that's why I always share with students, that's not very important. You just have to remember to add them together, because you're putting in the value for you to complete the squares, you see. So all this you just have to remember. You add on to the constant that you threw onto the right side, which became the, you know, the negative side of the whatever you had, you see. So that's why we had negative 35 plus 4 plus 36. That's very easy to memorize, in fact. Nothing to memorize, in fact, now come to think of it, right? So that's why I share it is easier to memorize sometimes, okay? Right, that's how we do that lah. So please think about it, whether you want to change your strategy or do you want to still keep on doing the completing the squares, right? But it would be good to know that this is a result of completing the squares, because maybe when you're doing your equation of overs next time, you probably will appreciate why you do a completing of the squares. Yeah. So that's how we do that. Given the equation, we can find the center and the radius. Okay. And of course this is the completing the square method, right? You can have a look at it. Alright, so now obviously coming back to applications, okay, and what type of applications are we looking at is, what if they tell you that there's a point and they're asking you, is this point in the circle, on the circle, or outside the circle, right? So obviously you know that if you have been able to find the points, you're able to find the points. Get its distance, okay? Let me repeat, get the distance, okay, between the point and the center. If you know the distance, okay, then you check yourself, is that more than or less than your radius, okay? No brainer. Look at it. If you are able to find the distance, okay, what is the distance from this and the radius, or rather the center, right? Get that and compare with the radius, okay? So this one you must know already. We keep asking you even at school, so you should know what to do for that. Right, so this one I'll keep that and move on. Now reflections, okay, this is actually something that you need to be aware, because I want you also to study it based on the type of question that they will ask. Even though I do not encourage studying based on every type of questions, it's like, okay, I give you the header, you go and do this type of questions like this. I prefer different variations, okay, because I want you to be able to apply concepts, you see. But you must be realistic. In examinations, we don't have time to really like think it again and do a lot of critical thinking. You don't do so much in exams already, because there will be definitely the tough questions if it comes out, but there should be just a few of them, not every one of them. So you don't do that, okay? But rather know this type of question that can come out, you see. So that's why there is still a need to learn the different type of question they ask. The major type, I should say, okay? And of course, if you have more time, you go and do a lot more questions and know and be aware of that the type of question that they can ask, okay? And this is something I need you to be aware, definitely, because they can ask this reflections, and it's no joke, right? So what about reflections like this? There are three types of reflection I probably want to know. Is but before that, maybe let's discuss what remains the same. Okay, key properties. Look at this. Circle reflections. What changes? I remember I asked in class, what do you think will change? So we must understand something, okay? Or rather should say, what will not change, okay? So obviously, when you have a circle reflections, right? So the radius doesn't change because it is still the same circle, you see. So please bear in mind that if let's say you have a formula already like that, for instance, let's say you have got a formula like that, or rather the equation of a circle, that is something like that already. Okay, let me just write this down. Please understand, a reflection means that you don't have to do anything here anymore. You can rewrite the equation of a circle, just that this and this might have changed depending on what is the reflection, right? Or the line of reflection, or the line of symmetry. Now the question is this, okay? So please understand, by default, if it is the reflections, okay, this one is the same. You just have to change whatever is here. So we must understand now. Only the center changes. Can you see? Notice only the center changes, and sometimes it will be very interesting. It's like not all the coordinates change, depending, right? So the shape and size remain identical. So it's more like a translation over here, right? So we know that the shape and size remain identical means that the radius is the same, just that the center, might have changed, right? Don't know whether it's X or Y, or both of them could have changed, you see. So we must know that for sure, Now there are two things you probably need to know at the tip of your fingertips. It's like, okay, reflection in the y-axis, okay? So what is this? Okay, so for instance, if let's say reflection in the y-axis, this is the y-axis, right? So if you have a circle like that, be it touch or don't touch, okay, the reflection obviously is here, right? The question is this, okay? You know that the center has changed, obviously. The radius is still the same, right? But let's review together. For instance, look at the left side over here. The center is A and B, right? So let me give you maybe a value. Maybe A is a 3, okay? Maybe B is maybe a 5, okay? So now if you look at this, and obviously if I draw something, okay, this is going to be my x-axis, okay? Just make it so. And this is actually 3. This is actually 5. So you look at it yourself, right? Okay, I reflect across here. Only this one has changed, right? No brainer. Is it not true? This is -3. So what is it trying to tell you? When you reflect about the y-axis, okay, the y coordinate doesn't change, right? Correct? So if you are given this, or even this, okay, you can change, but only the x coordinate. So for instance, for this diagram, I call that the B diagram, okay? Look at, or rather the W, look at the W example. If this is reflected across, or rather about the y-axis, right? So obviously this is going to be A equals to -3. The B is actually equals to 5, right? So this is what you should know, that's for sure, right? Now that is of course reflected about the y-axis. Of course, the same thing goes for the x-axis, which I'm not going to explain. Some of them has changed, okay? So depending what it is, okay? So this is what you need to know. Now, and of course, please have a look at this example with me. Let's say, look at this, okay? And I say that it reflected about the y-axis. So for sure you can tell, definitely your formula has changed. or rather the equation has changed. It's going to be like that, huh? And of course this one remains the same, okay, and your radius is still the same. It's actually 5 squared. Can follow? That's what you need to know. So that's how we do that. So reflection about the y-axis, reflection about the x-axis, okay. I mean, I put it there like that for you already. Please understand yourself, so I'm not going to share too much. The next thing, of course, is what about reflections like a line? You will test it in the worksheet, remember? But let's talk about this one first. I mean, I'll go through the fundamental first. What about if, let's say, it's a slanted line? This is something which I want to explain as well. Now, if you have a slanted line, right, okay, what happened is this. I mean, of course, for this one, it's easy. This one is like y equals to x, right? But of course, in your question, it wasn't like that. It was something else. But I want to bring to your attention on something else, okay? For instance, let's say the line is like that, and it has got a gradient, whatever. And let's say you have got just a normal drawing. Sorry about that. So this is, let's say, a -4. And of course 4, and there is this line over here, alright, of course, and they ask you what should this be, okay. Now for instance, you are given the equation of this line, just for instance only, so it's like maybe x equals to -4, so that will have to be x plus 4 squared, right? Okay, and of course this is going to be y minus 4 squared, okay. And let's make the radius easy for myself. Let's make it maybe like 4, or rather 2 to the power 2 lah. Make the radius 2. So I'll make this a 4. Now let's say you have a line like that, okay, and the question they ask you is, okay, can you tell me what is the equation of this circle? You see, can we do something? Now remember, when you reflect, something didn't change. By default, what didn't change? Radius is still the same, right? So the radius is still 4. Just that you do not know what is your, this coordinates over here. Correct? Now, question is this, okay? The thing is, if they give you a line, okay, we can do something, because you can tell for sure that this is going to be, first thing, 90 degrees, obviously lah, but I'm not talking about this. Rather, I would like you to know that knowing this coordinate is important, because if you also know this, let's say which is called the intersection, catch my keyword, intersection, I can actually get the midpoint formula, because from here to here, if it is D1, this to this is going to be D2, okay. And you can actually find this coordinate. You probably ask me, sure, like that, isn't it very difficult? Not really. Some of you did the displacement, remember? So you can do the displacement method, okay? So for instance, from here, right, okay, what was the new coordinate? Of course, you can do likewise from here to here using the displacement method lah. But you notice this question, you need to know what is this point, okay? And if you are able to tell me what is the equation of this line, and the equation, of course, of this line will definitely be given, find the intersection, okay. Later on we will see whether I have the time to explain that. That is from your worksheet. So if they give you something like that, not really y equals to x, but maybe like y equals to 2x plus 4, it shouldn't make it too difficult for you either, okay. You just need to find the equation of the line that is actually going to be perpendicular to the line that they have given you, okay. It's easy because the gradient is just -1 over whatever gradient that they give, right? Just that, okay, you need to tell me after that the equation of this line. Just use the value -4 and 4 obviously to find the equation of a line that actually cuts through this perpendicular to that line, and that the simultaneous equation, the intersection, will tell you this point, and that helps because you can now do maybe a little bit of a translation or displacement. Okay, find this one and then find this one yourself, right? Not that difficult, so that's how you can do that. Yeah, of course, like I mentioned just now, there will also be a need for you to know line, circle, intersections. The reason for that is because sometimes they will ask you, you see, like certain questions, right? Very, very direct, okay? Whether it is tangent to it, whether it crosses it, or whether it doesn't touch it, okay? Of course, for you to do that, you still have to substitute the value inside. So let me just go through with you. For instance, to solve line and circle equations simultaneously, that is assuming that they touch. Okay, so either they touch or they cut at 2 points. Okay, for instance, substitute the line equations into the circle equations. Okay, remember, catch what I say, right? Catch what I say. Substitute the line equation into the circle equations. Not the circle equation in line equation, then you die. Okay, don't do that. Okay, and then of course solve through quadratic equations, and the intersection points will of course be your answer lah. That's how we do that. Now, obviously they got other questions that they will ask in the worksheet as well. We did ask, like for example, can you prove that there are two intersections? Can you prove that there is just a tangent line? So when you substitute this line equation into a circle equation, right, rewrite it as a quadratic, expression or equation rather, and use your discriminant. Okay, so if it's going to be b squared minus 4ac, that has to be positive. So meaning that there will be two equations, okay, or rather two intersections, okay. But if your discriminant result in 0, that's for sure lah, it's just a tangent line. Okay, so you can do that in the worksheet. I'm sure you can do that. Right, the next thing, of course, this one most of you, I kind of felt that it wasn't really been gone through maybe at school. Tangents and circles, right? Remember, tangents and circle means what? Okay, a 90 degrees somewhere happens. Okay, and because of that, look at the circle. Let's say you have something like that. I drew that in the class as well. Means that the gradient, when you multiply both of them together, is equivalent to -1, right? So this is one thing you must know. So why is it important? Is because when they mention, for example, x squared plus y squared is 25 and point A is on the circle, they may ask you like, what is the tangent that go through that point, you see. So for instance, let's take a look at this example together. For instance, if they give you the equations of this circle as x squared plus y squared equals to 25, okay, and you probably know that the center is 0, right? But that's not my point. The point is this, okay, and they tell you, for instance, that 3, 4 is on the circle. Okay, so basically it's like, okay, this is on a circle, so means that it's on the circumference, right? And they ask you what exactly is the tangent to that circle. So what you must know is this, okay? So if you look at this circle, you must do yourself a favor, find the equation of the line that is actually perpendicular to the tangent first. That will help a little bit. For instance, you got this, right? And you know this is 3 and 4, and this is obviously 0, 0, right? The very first thing is, of course, find the equation, find the gradient. Okay, so the gradient for this, no-brainer, is 4 over 3. Can you follow? So this is actually 4 over 3, right? And of course, the tangent, like I mentioned, is always here. Sorry, it's a straight line, please understand. And of course, there's a 90 degrees over here. Now this means that this equation or the tangent is actually -3 over 4. Okay, so that means I can rewrite this tangent equation as y is equals to -3 over 4 x plus c. Okay, and of course you can substitute the value lah. X equals to 3, y equals to 4, and find the c, right? So that's how you can do that, just ignore this one. Okay, so that's how we do that. Pretty simple, And of course, like I explained, I want you to know there's such a thing called chord questions. Okay, what are chord questions? It's like they tell you that there are more. Let's say, for instance, the question says there's this point on the circle, and then they say there's another point on the circle. So if you know that there are 2 points on the circle already, activate in your mind, trigger, tickle you a little bit. It could be a chord question. So what do I mean by chord question? Is like, okay, I probably need to know midpoint, I probably need to know this and that. Okay, so very first thing, if they say let's say for instance you got 2 points, okay, right, so later on we'll go through the example if got the time, and let me share with you this slide first. For instance, chord properties. Okay, a chord connects 2 points on the circle. Now this is where it matches. Perpendicular bisector of chord passes through the center. So midpoint is important, because if you know the midpoint, okay, you can find the equation of also that passes through the center, and that is actually the perpendicular bisector as well. So this is going to be triggering in you, so midpoint might be very important because there's a 90 degrees there, and that also means that the gradient is, you know, m1 times m2 is -1. Okay. The center lies on the perpendicular bisector. Can you see? That's why I mentioned that. So how do you find the perpendicular bisector? Very interestingly, look at this, the gradient of the chord. Okay, if you can find the gradient of chord, go ahead and find that. And the perpendicular gradient will be, of course, -1/m, because m1 times m2 equals to -1, right? And if you can find the midpoint of the chord, that will be helping you to find the C in the equation of a line, and then you can plug it in. Okay, later let's see whether I have a chance to explain that in the worksheet. And of course, special chords you also need to know. I think sometimes they will come up with that. That is knowing that the two chords given are actually horizontal or vertical chords. Okay, because if you know that, it saves you a lot of time, right? If you know that these two are horizontal chords, vertical chord, okay, you will be able to see that, okay, the midpoint of this, one of the coordinates is the center, is the center of the coordinates, you see. So it saves you a lot of time, you notice. Yeah, so please bear that in mind. So we see whether we have the chance to go through that. And the next thing, advanced circuits applications. Okay, I'll just explain a little bit. Okay, for instance, there could be questions like that. They ask you, right, let's say the maximum and the minimum point on the circle. Sometimes they can ask things like this. Now if you know the radius, it helps you. Okay, it can help you a little bit. Okay, let's say for instance the highest point, for instance, let's say you have got, okay, let me just maybe explain. Not that difficult, in fact. For instance, you have got something like that, right? Okay, and of course this is maybe like 2 and 5. In fact, it's not difficult if you draw it out. If you know that the center is like that, right, and your radius is maybe like maybe 7. Let's say radius is 7, right? What they are trying to say is this: the highest point over here, which is actually the highest, obviously, is going to be just 2 and 12. This is the highest point, coordinates over here, because it has to be vertically above it, obviously lah, and of course the lowest point, no brainer, is just 2 and -2. Okay, this is just what we meant. You must know that actually, because it helps a little bit. Sometimes they will just say, okay, this is directly, or they can tell you that there's a line that is actually flat like that, you know. So it helps if you know that. For instance, if this is y is equals to 12, right, and you know that the radius is actually going to be maybe like 7, and they didn't tell you the coordinates over here, you can actually derive it on your own just by subtraction, you notice. So that is also very important, so knowing the highest point is important as well as the lowest point. That helps if they give you, you know, something like that, you know. And of course the leftmost point is obviously adding the radius to the x-axis, x coordinates, or subtracting from it. Okay, so that you if they ask you for a vertical line, okay, and you can also find your x-axis, or rather the x coordinates. Okay, that's how we do that. So max minimum point usually is more applicable in telling you, you know, there's this straight line, a flat line we call that, you know, it's actually touching the circle, you know, so that can trigger you that this is the max and minimum. Okay, and of course what else can we share? Okay, for circle that touches both axes, okay, so you must by default, if they say that the circle touches both axes, right, by default the center is just the radius comma radius for sure. Okay, so do that be in your system. Okay, by default, if both of them touches the axis, okay, that depends lah, obviously, if it's on the left side or the right side lah. But if let's say it tell you that, okay, positive x and y axis lah, then you can very clearly say that your center is R and R. Okay, but you might ask, sure, what if they don't touch this axis, they touch at the third quadrant? So let's think about it. If it touches the third quadrant, what should your center be? Okay, let me try to draw. So if it touches the you know, over here, sorry about drawing. So let's say it touches here. Okay, your radius, let's say, is already known. Let's say it's a radius of 5. Okay, so by default, the center, alright, I will call that, okay, RR first. Just do some correction later. Okay, now we discuss, ask yourself who is actually negative over here. Both of them are negative, you notice. So it's going to be negative R, negative R. So for instance, the center will obviously be -5, -5. Okay, it must trigger in you. So for instance, they say that this circle touches both axes. Radius, you know, is 5. So center, default, RR. Okay, that's how we do that. So that's what we can do. So let's just do a summary. Key formula, you should know that already. Standard form, general form, right? And of course, distance formula you must know, because if you can tell me the points on the circle, you know, getting the distance formula can tell you the radius, right? So please understand that there are key techniques you need to take away from, like I just explained. Completing the square allows you to see how we can derive the radius and the center coordinates from the general form, right? And I want you to bear in mind about this perpendicular gradient. Okay, now I want you to not just remember perpendicular gradient for tangents, also remember perpendicular gradient to chords, you know, the midpoints. That will also be very, very important. Alright, simultaneous equation for intersections, that is for, you know, this line and circles. Distance comparison for points position, that will be, of course, if it is outside or inside. That's one thing. That means the point is it outside the circle, inside the circle, or whether it is actually the maximum point or minimum point, leftmost point or rightmost point. Okay, that is, of course, the key techniques. Just remember. Last one, applications. Okay, what if you are asked for reflections, especially reflections? So what about reflections? What does not change? Is it radius doesn't change? Okay, that's what you need to know. Chord and tangent properties. This is linked to the key technique number 2. Remember, you can also use midpoint. You can also use the perpendicular gradient. Of course, last one was just what I've just mentioned. Max minimum point on the circles. Okay. Right, so I've just covered just the basic concepts, okay, and of course I will share with you the solutions for your worksheets in time to come. Right, so for the time being, please take some time to actually do the worksheets again if possible. I'll see you again when the term starts. Okay, have a good time. Bye bye.